Yeah, so today we're going to talk about SQL injection. Um, oh, someone in chat, I don't know if there's something wrong. I don't know. I'm going to continue, but yeah, today we're going to talk about SQL injection. Um, it's a common website vulnerability which basically allows an attacker to access a website's entire database without authentication, and it's extremely ubiquitous because most databases rely on SQL or SQL, as some people might call it. Um, and yeah, most websites use a database, so it's really common. Um, and yeah, most websites store some amount of personal data, so it's really important to prevent attackers from accessing the database because you don't want to break GDPR. That would cost you a lot of money. Um, but yeah, sorry, why isn't it working? There we go. Um, so the source of the attack is usually some form of text input field where the database uses the information you enter in a query, but instead of entering like normal stuff, an attacker will just enter malicious SQL, which then gets executed by the database. So I'm going to just show a simple example. Um, So the classic example is just a login screen. So the typical SQL query might retrieve any users that match the username or password combination. This is a very naive implementation, but basically, yeah, just imagine this is the login screen, and I type in Bob and 123456. It it might, yeah, I know the J-hipster login, isn't it amazing? Um, it might directly feed these inputs into a query like this. So it might select all users where the username matches and the password matches. Um, I mean, it seems like it will work, and it would work, but it's not secure at all. Um, yeah, here's just like an example code which forms the query. So it would be concatenated using strings like this. Um, and then if it finds anything, they log in, and if it doesn't, then access denied. So yeah, that's the query. But this is not a good way of coding. It's very insecure because an attacker can exploit this to bypass the authentication checks entirely. Um, they can enter a string such as this, which looks like nonsense, but basically it forces the database to execute a different query. So instead of checking that the username and password match, it checks if the username is nothing or 1 equals 1, which is always true. So it's always going to let them in, which is bad. Yeah, which is what that sentence says. Um, why does it work? Well, basically, they first enter a quote character, which ends the string for username. So now the SQL query will think the username is nothing, and then they'll write their own code, which is always true. Then a semicolon ends the query, and they use a comment to just ignore everything else so that it doesn't like cause an error, so that it actually does what they want it to do. And comment is usually 2 dashes. Um, yeah, but they could do literally anything after this semicolon. Like bypassing authentication is bad, but they could also write literally any SQL statement here, like maybe drop table users, which is pretty dangerous. So we want to prevent this. They are shockingly prevalent given how easy they are to fix. So there's a few main measures. The easiest one is input sanitation, which just takes any characters which could be used to execute SQL and just escapes them. So if like if a quote character was entered, then it wouldn't be treated as an actual quote. It would be ignored. Um, yeah, like they might have a backslash inserted before it. Um, the same. There's another thing. Input validation is similar, except rather than like filtering out the characters, it just rejects the input. Um, but there's a few problems with those. I'll get onto that later. Prepared statements are the way to prevent SQL injections. Um, the inputs are basically inserted as like parameters. The query is fixed, and it means you don't use any string concatenation. So the inputs are never actually treated as code. And yeah, this is the best way of dealing with it. Um, I'm going to go into a bit of like how we analyze attacks and like the kind of types of SQL injection attack, because that was in the slides. It's a bit of waffle, but it was in the slides, so yeah. There are three main like parts. So there's the root, which is like how did they actually gain access to the database? Like what part of the website is vulnerable? Um, Motive, what do they hope to achieve? Why are they accessing your database? Code, and then what is the code they actually ran to hurt your database, if that makes sense. Um, there's also three kind of tiers of the attack. So there's the presentation tier, which is basically any information that's available on the front end. So um, anything that's displayed to you, like the URL or the actual front end website. There's the logic tier, which is basically any processing done between here and here, um, like maybe any formatting that's done on data before it's displayed to you. And there's a storage tier, which is just it's just the database. It's where it's stored, and it's where the query is executed. Yeah. So there's many kinds of routes that an attacker could use to perform an SQL injection. They might not even seem database related at first, but there's quite a few. I mean, the classic example is a user input, like a text input on a form. It's the most obvious one, but there's a few less obvious ones, like cookies or local storage. They could always just modify that. If it's used in an SQL statement, they could just modify those. URL parameters. The URL is never a safe place. API calls, even. They're also a form of input. This was in the slides. The second order injections, like if they set up a backdoor in the system, they could just use it to perform an SQL injection. Yeah, something about URLs. Like even if an input isn't obvious as an input, it's important to consider it. So HTTP query parameters can be considered an input. They're basically found at the end of a link, and they contain information about the state of a page. So common use of this is for search queries. So if I was searching for this product, which I can't afford on Amazon, then it might add this at the end of the link, and it might directly concatenate this into an SQL statement, like searching for products where the name is like this. But this is bad, of course. It's like you could easily just enter SQL code here. It's not a direct input on the website, but you can just modify the URL in the address bar of the browser. So basically, literally anything which the user can edit that gets sent to the backend must be considered an input. Never directly feed them into an SQL query like this. As much as I would love to use this to reduce the price of that product, yeah. Anyway, um, Okay, there's many motives for an SQL attack, like SQL injection attack. Why would they want to do it? Um, these are like the motives of the actual SQL injection attack. Yeah, sorry, I'll get onto that. So they might want to steal data in the database or modify it. Um, Obviously, they might want to bypass login screens. They could use it to mount a DDoS attack or something like that, or even like inject malware into the system. Um, there's also some auxiliary motives. These are just like motives which, in order to do an SQL injection, the attacker needs to know this stuff. Like they need to know the structure of the database, or they won't be able to execute valid queries. Um, they might need to escalate database privileges if they're like not allowed to execute certain commands, and they might need to find which inputs are actually injectable. I'll go more into that in a bit. Um, yeah, these are. I'm going to go into the kind of types of SQL injection attack. These were listed in the slides for security networks. Um, yeah, I'll just provide a list here, but then I'm going to go into more detail about each one. But yeah, so a tautology attack is one where they just use a Boolean value that's always true, like before. Illegal queries, they might purposely cause errors in the database, um, purposely cause it to return errors, which I'll go more into. Um, Union queries, retrieving data from other tables, that's bad, obviously. Um, Piggybacked queries, executing another query as well as the intended one. Inference pairs, this is all about learning database structure. I'll go more into that. Stored procedures, this is basically executing macros that are stored on the database, um, like SQL macros. And they might exploit features which were used for convenience during development. Oh, I've just seen a question. Um, the difference between illegal queries and inference pairs. Um, Illegal queries is specifically looking at error messages, and this is looking at. Oh, wait, that's wrong. Yeah, no, that's not meant to say error messages because that doesn't use error messages really. I'll go more into that. There's a whole slide on it. Um, it's fine. Thanks. Uh, tautology attacks. Tautology attacks. So yeah, they use a Boolean value which always evaluates to true. Basically, they can just bypass any check. Um, so the classic example is a username check. The problem with these is they're really difficult to filter out because there's so many ways of creating a tautology. Like you could use literally any number here instead of one. Um, like the classic way is just comparing values, like greater than, less than, even string comparisons. Um, quasi tautologies are statements which are almost always true. So maybe generating a random number or even checking the date and time. I don't know if this is a thing you can do in SQL, but the attackers are clever. They'll probably come up with a way to do this somehow. Um, Contradictions are statements which are always false, and these can just be negated, like not this, and then used exactly the same as any of these. So it's input sanitation and validation are not effective against these, which is basically the reason we don't use them. We use prepared statements. Prepared statements are the best. Right. Union queries. So this is just basically where they access other tables in the database, which obviously could leak data. This depends on the permissions of the database and how it's displayed to the client. So basically, if in a search bar the attacker entered this, which basically just says, as well as selecting all the products, select a credit card where the account number matches this number. Um, if this data is actually shown to them, like if the raw output of this is shown to the client in any way, the attacker could literally see this credit card details, and that's bad. Um, Always format data before sending it to the client. One does not simply display the raw output of an SQL command. You'd be pretty crazy to do that. Yeah, always format it. Um, Piggybacked queries. This is just It's kind of similar to union queries, except instead of using like a inner join or anything, you just execute another query, um, which could be literally anything. So you could steal any data you like or delete any data as long as you know the structure of the database. So there's the famous Bobby Tables attack, which is basically where you enter this as a username, and instead of checking your username, it deletes every user in the database because what's this? Basically they end one query here and just write another. Um, yeah, so it's really important to limit the user permissions of the database so that dangerous operations like drop or delete are limited to admins, and you've got to make sure your website isn't executing SQL with admin permissions. Make sure your website is executing SQL with the correct level of permissions. Never use admin permissions just for everything. Um, but of course, the best defense here is prepared statements, because that means only your intended query will ever be executed. It won't ever execute anything else they type in. Of course, it's always a good idea to back up your database in case the records are somehow lost, but that's unrelated to SQL injection. Um, Illegal queries. This is basically where they cause an error in the database, which displays an error message to the client, and this basically gives the attacker like clues about the database structure. So like the names of tables or like the data types of a column. All of this stuff is useful for someone doing SQL injections. Yeah, it's like scouting purposes. So they might want to determine which fields are injectable, what type of database. So like Postgres or SQLite or like Microsoft SQL Server. They all use slightly different dialects of SQL. Um, it's not usually major differences, but usually stuff like some dialects use semicolons and some don't. Some use like different comment characters, but they need to know this in order to get their SQL injection syntax right. Obviously, table and column names for actually retrieving data. Also, databases have many like users and permission levels. They might want to see which permissions they can exploit and get into without permission. Um, but of course, this illegal queries are rendered useless if any error messages, like including database information, is just hidden from the client. Don't just directly show error messages to the client. Um, it's important to consider the development console as well, not just your front end. So hold on. Can you see? Is my stream still working? Wait. Oh my God. Wait. Oh, did it just turn off when I quit PowerPoint? Oh, right. Hold on. I was trying to show you something on my browser. That's why. Just so everyone knows what the development console is. Press F12. Yeah. Don't show database error messages here. An attacker could use it. You can see this, right? Yeah, great. Yeah, don't just console.log all the time. Make sure if you have any debug things, um, don't put debug console.log statements into your production website. That would definitely give them clues about the database structure. Anyway, um, back to this. Um, yeah, inference pairs. You can see the PowerPoint, right? Okay, good. Um, Inference pairs. This is different to illegal queries. Basically, even if there are no explicit error messages from the database visible to the client, the attacker can still kind of figure stuff out based on like subtle differences between outputs. So basically, hold on, let me get my. They'll use this to determine whether an input field is actually injectable. Um, so there's kind of two types of this. I'll not go into them. There's the blind injection and the timing attack. So a blind injection is basically where this is why they call it inference pairs, because you do two kind of test injections. You first inject a true value and then a false one, kind of like a tautology and then a not tautology. Um, so in the username field, you might put this and then receive invalid password, but then you might put something which is always false and get invalid username and password. And basically, this tells the attacker that this was successfully read as true because it didn't say invalid username. They know that this worked, that this field is injectable. Sorry, question. By doing SQL query pairs tells us, I mean, yeah, it kind of tells us about how, it doesn't really tell us about the actual, like, code. Like, it doesn't tell us about the, this name of the parameter or any table names or column names, but it tells the attacker that a field is injectable. Um, and even if they don't know table or column names, they might be able to guess them. I mean, it's pretty likely there's one called users. Um, I don't know if that was the answer you were looking for, but I hope that helped. Uh, cool. Um, the second attempt, it might seem a bit pointless, but it's kind of like a control variable just to make sure the website isn't glitching and that this is actually working as an injection. Yeah. A timing attack is a type of inference pair. Basically, even if these both say just invalid login details, even if this doesn't give you any information, like they could try and force a delay in the server's response. So basically, they input this as an injection, and basically it will say if something always true, sleep for this long. So then basically if their injection worked, it'll wait 5 seconds and they'll know. And then they'll use a control variable like this where if always false. So basically never sleep. This would respond instantly. Um, but yeah, even without differences in the error message, they could figure out if a field is injectable just by using a sleep command. Um, yeah, so use prepared statements to stop them from executing code. Um, Stored procedures. These are basically like macros for like commonly used SQL queries, um, like maybe for convenience during development. Um, they're usually used, yeah, like usually just for like common queries, but they can actually execute shell commands on the database server if you use certain tricks. And if an attacker manages to somehow inject into one of these like stored procedures, they could literally execute shell commands, giving them like basically full control of the database server if they manage to get like admin on the server. Um, yeah, that's bad. Even if it can't access the shell, this a stored procedure could still be a risk if it runs with like admin privileges or accesses like hard-coded secrets or any other kind of confidential information. Don't hard code secrets, by the way, like API keys. That's pretty stupid idea. Um, wait, there's a question. What I mean by a macro is kind of like it's kind of like a function. It's like you save an SQL query as like a function that you can just call at any time without having to write it out every time. Um, that's kind of, yeah, cool. Um, yeah, even if you don't like hard code secrets, that would be a stupid thing to do. But even if your stored procedure is written well, if it accesses files, um, like because some database system literally allow for like file handling. Um, can anyone in the chat tell me why file handling might be a bad idea? Yeah, basically, just they could literally write a shell script, and then it just becomes a shell injection again. So never allow file handling. Yeah, basically, don't use procedures for you can use stored procedures, just don't use them for anything that's potentially dangerous. Like you don't want a procedure that promotes someone to admin or something. Um, Never use shell operations because they could just be injected into. This is disabled by default in modern systems anyway. Don't enable it. Um, Always disable file handling operations. Most systems don't have this, but yeah, never use it. And just use prepared statements, okay? If there's one thing to learn from this, just use prepared statements. Um, yeah, right. I'm gonna go a bit more into how we can prevent SQL injections now. Um, because input filtering, um, is it might seem like this is like input sanitation and validation. It provides like quite a good baseline, but they're not foolproof. Like attackers have so many creative ways of bypassing filtering systems. Like they might use like special Unicode characters or something. Like there's so many types of quotes or like characters which SQL might recognize that you might not have accounted for in your filtering system. Like it's hard to know that you've accounted for everything. So this is why prepared statements are just the best. Basically, only your intended query will ever be executed. Nothing else will be treated as code. All user inputs are escaped. They're treated simply as string literals. Oh, SQLI is just SQL injection. It's just easier to write. But yeah, all inputs are never treated as SQL code. Um, they're really easy to use as well. They're so easy. Basically, in Python, here's an example. You just connect to your database and um, get your inputs, and then basically there'll usually be like this function for executing a prepared statement. In Java, this is a bit different. I think you have to like initialize a prepared statement object or something, but the idea is the same. You just input your query like this with question marks, and these question marks will be replaced with whatever you pass in over here, and whatever you pass in will never be treated as code. It's that simple. No more string concatenation. It even looks cleaner in the code. Yeah. Um, it's important to consider SQL injections at all stages of development. So pre-deployment, like during development, you got to have good coding practice. So like the most common cause of SQL injection is just poor coding. Just don't use string concatenation. There are automatic tools that exist for detecting suspicious coding patterns, and they can like analyze the data flow of user inputs to make sure they're not being directly fed into SQL statements without like prepared statements. Um, Even if somehow some dodgy code gets through the development, penetration testing can make sure you go back and fix it. Basically, there are automatic tools that can test every input in your website for SQL injection vulnerabilities. Um, and yeah, then they'll flag it and you can go fix it. And even after you've deployed your website, you can manage your database securely. Um, so you can basically just make sure that admin privileges are not thrown around and used everywhere. Make sure they're managed carefully. And I mean, after you deploy, there's so many other threats to your database, like that aren't even SQL injections, like that, but you can prevent them with like network related protections, like firewalls. Um, yeah, but that's out of scope really. Um, oh, final slide. So these are just some extra prevention measures. I don't know if we have to know these, but these are mentioned in the slides for S for in the lecture slides, and you could pass user inputs through a state machine to basically just make sure that the query is in the correct format. So if anything like unexpected is found, I'll show you what a state machine is in a second. It's like a DFA from theory of computation. Um, but basically, it's if anything that's not expected is found, an error state is reached. So it'll specifically look for these things, and if anything is wrong, like if it encounters like or 1 equals 1, it won't reach the goal state, and it'll go to hell, as Paul Levy used to say. Um, yeah. There's also a system called SQL Rand, which basically it uses a concept called instruction set randomization. It's basically where all the keywords like select from, they're kind of like randomized or encrypted technically. Like they're just garbled up so that your SQL dialect is like completely different, and an attacker won't be able to write valid SQL queries. Um, if that makes sense. Yeah, but that's all really. Thank you for watching. Yeah, thank you all. I'll see you soon then.